So today, let's talk about the schematic, and basically what I want to do is get some two-way conversation going by asking you good people out there whether I've got enough functionality or whether you've got any suggestions for the design. So I'm not going to go through this schematic in detail because I've done a previous series on the making of mutable instrument stages, so you can get a lot of info from that. But just quickly to go over it, you can see the microcontroller there. And let me just run through the functions really. So I've got clock input from the rest of the system. I've got a connector there for the LCD display. I've got a programming header there. And on this side we have a bunch of inputs to the microcontroller to control its main function. So we've got play program, so that changes the mode from play to program mode. Knob value, that controls the beats per minute or fast forward when we're in program mode, so that enables us to move around the grid faster. Instead of moving one grid square right, left, up and down, we can go, I think I've set 8, 16 and 32 steps instead of one. Also we've got move right, move up, move down, move left. Excuse me, sorry about that. We've got a return function which, no matter what position you are in the grid, it will quickly go back to bar 1. We've got a load function and a save function. I've now implemented 3 memory slots instead of the 1 that I had previously. We've got a toggle function, so that either makes one of the grid squares play or not play, and I've put a spare output in there, so if there is any future functionality we can use that later on simply by reprogramming the microcontroller. Moving on to one of the other sheets within the design. Basically the microcontroller, for example, has an output which goes to pin 3, which is that CH1 there. So on that particular chip there's CH1, CH2, CH3 and CH4. This is an analog switch. I'm not going to go into the functionality of that, but I've got 4 channels there, 4 channels on another one, and these are more simpler kind of circuits where it's just a single pole single throw switch instead of single pole double throw, but in total I've got 16 channels there. So if we go back to the base or root sheet and then go into this one, I've also had a bit of space on the board left over, so I created some a gate output. So not only does it control one of the analog switches which I've just referred to, it changes the output from the microcontroller, which is 0 and 3.3 volts, and through that transistor circuit it creates 0 to 5 volts, non-inverting on channel 15 and also channel 16. So that's all I've got on there at the moment. Be great to hear your kind of suggestions, advice on what else maybe I could do with this. Obviously there is more stuff. I have actually set many of these pins as not connected, as you can see there with the crosses on. I don't know if you can see that, zoom in. So there are other things that we could do. I've got plenty of space left in the RAM space for the program. Probably only used about 12% of the capacity, and probably about 10 kilobytes of flash memory for the 3 memory slots. So there's quite a lot more we could do. So just quickly, I have created a PCB of this initial design. There it is. What would be nice for you guys to come back to me with your suggestions, and I might actually put some of those in here. We'll see. So hopefully get back to us soon, because I really want to get this in production in the next couple of weeks. Thanks. Bye bye now.